Hey guys, this is John Kalam from Kuhol Garage, and I'm pleased to make this video to tell you guys that we are finally in process of building our 4G63 rear-wheel drive engine. The previous video on that engine is we were supposed to assemble everything, get it running in as quick as possible. Unfortunately, the ancient Series 80 G63B 6-bolt block. We did check the deck surface of the block. We have found it to be warped, unfortunately, so we needed to send the block to the machine shop. And also at the same time, we also sent the twin cam head that we were planning to use. Aside from the block being warped, the deck surface being not straight, the head also needed some work to be done. So finally, we were able to get the block back from the machine shop, and it took ages. Not necessarily the machine shop's fault. We had a lot of things machined in order to do the setup that we actually want to do. And so we kind of wanted to build a robust, stout engine with as much OEM parts as possible, and yet build also a responsive engine that's gonna be turbocharged, about 250 horsepower at the wheels. Okay, I'm not talking about four-wheel drive, so it should be easier to achieve with a rear-wheel drive drivetrain. We took the advantage of also changing aspects of the bottom end. First of all, we kinda had to resize the crank journals. Undersize them 0.5, and very surprisingly, the 6-bolt, the early 4G63s share the same main bearing specs as the 4G32, 4G33. So to have the main bearings be the same as a 4G32, 4G33, that was interesting to me. Thankfully, here in the Philippines, the 4G32 and 4G33 engines are very, very common because the most popular car in the 1980s was the Lancer box type. There's a boatload of those cars still running, and still people are very enthusiastic with the Lancer box type. So luckily, there's a lot of part sharing that we are utilizing from the local market. What is difficult, however, was to source the pistons that we needed and to mount said pistons to the connecting rods. As you guys know, the 6-bolter has these very, very thick connecting rods. So we wanted to utilize those very heavy-duty connecting rods as compared to the OEM 7-bolters that came afterward, which Mitsubishi decided that they don't need that much strength in the connecting rod, so they undersized the thickness of the rods. I was very much inspired by one of my racing mentors, the late Mr. June Espino, who told me a story when they were rallying the Galant VR4s, that whatever boost they were doing, they could not bend the connecting rod. They would break other engine parts, but not the connecting rod. And the Galant VR4s were running 6-bolters. I have some extra 6-bolter rods, and we decided to fit those rods into higher compression pistons. And so we wanted to run as flat top a piston as we could. We decided to use G4JP Sonata pistons, which were a pain in the butt to source. And I had to get them from Korea. This is the one special weird part. I think what I should have used instead were Honda K20 pistons or some other piston that was more common rather than these cast G4JP Hyundai pistons. They are pistons that are for the 4G63 anyway, except that they don't fit the connecting rod. The 6-bolt connecting rod has a 21mm piston pin diameter, but the newer generation 7-bolters, including the Hyundai G4JP or what they call the Sirius 2, the newer ones are running 22mm pin diameters. So we kind of had to have that done, to have the connecting rod machined to accept the 22mm piston pin, and also to narrow the small end a touch so that it fits inside the pistons. As of today, we have assembled not all of the bottom end, but a vast majority of the bottom end. The stock 2-liter crank from the 1980s engine. We're using modified connecting rods for the 6-bolter. We're using Hyundai G4JP Sonata pistons. In order to convert the engine to a twin cam, we had to replace the oil pump assembly from a twin cam. And so a long time ago, we were able to source not only the head, which came from a Galant GTI, but also like stuff like the oil pump, all the sprockets and doodads and whatnot, in order to swap over the timing belt side components. We used the original rear-wheel drive crankcase that it had. We retained using that because it has an inbuilt oil return drain. Unfortunately, I don't know as yet how to put an oil filter on the car because the oil filter location conflicts with the oil drain location. So either we have to modify the oil drain or we have to modify the oil filter. Thankfully, oil filter relocation kits are not expensive from Lazada, and I may have one somewhere in the bunch of parts that I have. So maybe I try looking for it before I buy. But besides that, we don't see any issues on assembling the engine. We're just waiting for the head. The head is from a Galant GTI as well. It's a first-gen twin-cam head, so it has those massive intake ports. We're still figuring out how to mount our modified Evo 4 intake manifold. So we're thinking of making some custom plates or something, or adapters, so we could port match properly the intake manifold to the big port head. So we're still in process of have that made. Since we're using the Evo 4 to 8 manifold, either a cast or a tubular item, we could use an external wastegate with that tubular manifold. Whatever the case, we have a choice of 2 turbos. Both are OEM. We have the Evo 4 turbo, and we also have an Evo 6.5 Tommy Makinen turbo with the titanium aluminide turbine wheel. The Evo 4 turbo has a 9cm housing, while the Evo 5 turbo that we are using in Project Itoy all-wheel drive is a 10.5. Then the Evo 6.5 turbo, the Tommy Makinen turbo, again has that titanium aluminide wheel. They say it's a faster spool. There are aftermarket turbine wheels that are quicker spooling than OEM, and there are better compressor wheels that could boost at higher boost pressures than OEM. You could buy that from a lot of Taiwanese suppliers. So our power goals are modest for this engine, and we kind of want to use as much OEM stuff as possible. So the engine is not that, not that sophisticated. It's not built carefully. It's built normally. So everything's OEM spec except for the piston ring gap. Since we're going to be turbocharging a piston designed for natural aspiration, we kind of needed to increase the gaps more than standard. The downside of that is our engine might smoke a little bit when cold. Push comes to shove, at least we're not going to be having ringland failures because of the expanding piston rings due to excessive pressure. So we'll take a little bit of smoking any day. And one last thing we had machined, it's nothing to do with the engine but everything to do with the transmission. Okay, so we're running a KM132. It came with the engine. I think the value proposition that the engine had was not really the engine itself, but it really was the transmission that it had. Clutch is hydraulically operated and it's not cable type, so that's a good thing about this particular KM132. Given the fact that we needed to go to the machine shop to have the engine done, we kinda also had the flywheel modified to fit a 240mm clutch disc. The splines on the clutch disc for an Evo 7 clutch will also work with the KM132. The problem is the pressure plate needed to be a push type instead of a pull type. So going back to Project Coupe all-wheel drive, we went shopping again with Korean car parts. We just bought a Hyundai Starex clutch disc and Hyundai Starex pressure plate. And the release bearing will be L300 gas. But thankfully, the clutch for this car and future clutch replacements will not be very expensive and will not be very difficult to find, because we are just going with OEM stuff that would be easily sourced, easily available from wherever. The only thing weird about our engine is the Sonata pistons, which are a bitch to find. But if we could not find it, we could always go back to Evo 4 pistons. But besides that, the engine, there's not much trick to the engine as of now. And thankfully, also the clutch, which probably we're going to be we're gonna destroy it as we learn how to drift. At least we're trying to make sure that we could afford a clutch to burn it, while at the same time have a clutch that could handle more power, more torque. Okay, so if it's good enough for a commercial vehicle, it should last us but a decent amount of time for our motorsport use. Our goal is to get the engine assembled as soon as possible. Alright, so those are the updates for our 4G63 rear-wheel drive project engine. I hope to see you guys on the next series of videos that we're gonna do about this engine and for its future chassis. If you guys have any questions, please feel free to jot them down. I exercise the right to attempt or not attempt answering them. But anyway, guys, that's it for this video. I hope to see you guys next time. Ciao.